Good morning, good afternoon, good evening, depending on which time zone you're in. I'm Ian Tabor, or at Minternet. This is my talk for Car Hacking Village 101, Cluster Fuzz, starting out car hacking on the cheap. First things first, who am I? You could say I'm the ultimate car hacker. I built this kit car 15 years ago now. It's based on a mid-1990s rear-wheel drive Ford running gear. However, it has a Ford Focus engine from around 2004. Doesn't weigh a lot, has quite a bit of power. It goes like stink, great fun to drive. It's not that complex vehicle. It only has 3 ECUs, 2 of which I built myself, both of which talk CAN. So you could potentially hack this vehicle. Please don't. It's great fun when it's driving. It's not fun when it's not. There's a little disclaimer down the bottom there. Car hacking is done at your own risk. If you brick your own car, please do not blame me or the Car Hacking Village. So onto my car hacking credentials. In 2007, I hacked my own vehicle, found an issue in the head unit in which you could get access to personal information inside the head unit quite easily. I disclosed that information to the manufacturer itself. I then did a talk about it at DEF CON group in London, DC 4420, B-side London Rookie Track, and DEF CON 26 Car Hacking Village. In 2018, I was also invited to be one of 12 security researchers to go to BugCrowd's live car hacking event. I then returned in 2019 to be one of 20 security researchers to go to the same event for the same manufacturer, but at their factory over in the US. Last year at DEF CON 27, I was part of a BugCrowd car hacking panel with Cybergiddens and Spectres, hosted by Chloe. I was also asked last year to go to the Auto Isaac Summit in Texas at Toyota's plant, where me and a couple of others were part of a car hacking vulnerability disclosure policy panel for HackerOne. I also now, for my sins, run the Car Hacking Village in the UK. I have my car in the box, PD0, which is all the electronics from a Peugeot 208 in a box in quite a portable form. Not as portable as being globally movable, but last year I did about 13 events, one of which was in Europe. I have been asked to take it all the way around the world: India, Australia, Brazil, America, Egypt. The only continent I don't think I've been asked to go to is Antarctica. This year I was meant to do B-side Stuttgart, B-side Brussels, but things have happened, as we know, and there's been quite a few virtual conferences, which also means my car in the box will be available for the virtual.carhackingvillage.com CTF. If you look for PD0, there is 2 Raspberry Pis attached, one on 2 of the buses, one on the 3rd. You can then basically hack that vehicle in a safe manner. You won't break anything really unless you try really, really hard. It's quite good that it's actually going to be used at DEF CON without me leaving my own home. I will miss the people. However, travel is not really fun at the moment. So there are some hints and tips for the CTF for the Car Hacking Village 101 in this presentation and the fuzzing that I will show you. You may want to pause and rewind some of this at a later time, but I'm not going to give you any more hints than that. So where do we start? The assumption is you all know what CAN is, Controller Area Network. It's a differential signaling communication system that allows lots of devices on a single bus to communicate and has an arbitration system to allow the most important message to go out first. You don't really need to know much more about that, but if you want to have a read, Car Hacker's Handbook by Craig Smith is a good read. So first things first, you need a cheap CAN adapter. I will go into those in a second. Once you have a cheap CAN adapter, you could try reading your own car. Be very careful if you do. I plugged in one of my own home-built CAN adapters into my 2017 Jaguar XE and managed to make the car lose its gearbox. Yeah, that was one of those moments where thinking, oops, I probably shouldn't have done that. And I was thinking pound signs. I did manage to get it back eventually, but it involves disconnecting the power for a considerable length of time, about 20 minutes, plugging it back in. All the messages were then reset. However, the next morning when I went to drive it, it took about 3.5 weeks to learn how to change gear again because it had the automatic ZF gearbox from as used in a lot of automatic vehicles these days. So slightly easier and slightly less dangerous is testing something that you can actually use outside of the vehicle. Do not test on your own vehicle, because if you break your own car and can't get Johnny to school in the morning, your missus will kill you and you will be doing the walk of shame in the rain. Not a good idea. So I'm going to show you an instrument cluster that I have. I will show you how to interpret a wiring diagram, what then is required for power supply, and then some tools that you can use. And I will show you some fuzzing, and you can see some results on the screen of what's actually happening. So first things first is the NanoCAN adapter. I use this device as the PCB itself as my business card. I started doing it in early 2018 when I first started the car hacking village, in that it was something I could give away at the conference to say, here's a way to start doing car hacking. All you need is $5–10 worth of components, which include an Arduino Nano, an MCP2515 module, bit of wire, the PCB, and the OBD2 plug as shown there. What you would then do is solder it all together as shown on the GitHub instructions. You then can program the Arduino Nano with a basic sketch that reads all messages, and you get an output like this. You can reprogram it with other sketches that allow you to read and write data, but unless you know what you're doing, have a play with something first, listening and not sending. Here is the same output, but using PuTTY to interpret the data instead of the Arduino IDE. Again, if anyone wants one of these PCBs, hit me up on Slack or on Twitter, or email me if you want to. I will put it in the post. If you're a distance away, it might cost you the postage, which isn't that expensive. However, at the moment, postage around the world is getting silly because of COVID costing extra money. But hit me up anyway. I will be online after this talk on the Discord channels for questions, etc. Here's a second one of my adapters that I built. That is a pound coin 4 scale. That little device there is based on an ATtiny 1614 processor, which costs about 50 pence or about 50 cents, maybe a little bit less if you buy quantity. It uses the same MCP2515 CAN controller and a SN65HVD230 CAN transceiver from Texas Instruments. The other two are from Microchip. And this will allow you to build a CAN device for probably less than $3 for all the components there. However, you need some extra parts to actually connect it to the vehicle if you want to connect it to the vehicle. There are two versions of this board. The red board is the main brains. The other board behind it, the little blue board you can see there, has the power supply and the connectivity onto the CAN bus. This one here is for nefarious purposes, in that you can program the board at the top to listen for certain messages. When it sees a certain message, it can then start sending messages back onto the bus. This is powered from the CAN bus port. The blue PCB in the middle has the power supply that brings it down from 12 volts to 3.3, and the plug at the back will then go into the CAN OBD2 port and allow you to do various things. Be careful when you're doing this. Again, you could break things unless you know what you're doing. The other version of the tiny CAN adapter is here. This is a green board in the middle. This green board has an extra connector for a USB to TTL adapter. This adapter allows you to connect it to a Linux system using SL-CAN, so serial line CAN and socket CAN and CAN utils. You can then send messages from the Linux system using CAN utils, which I will go into in a second. This again, all of the hardware there is probably about $7 worth of hardware. At some point in the future, I will put this up on GitHub as another repository. If you want me to, just pester me, I'll do it quicker. Another cheaper CAN adapter you can use if you've got a Raspberry Pi lying around doing not a lot. Here is the Pi CAN for Raspberry Pi. This is made by SK Pang in the UK. It uses the similar microchip CAN transceiver and CAN controller. However, it's got a DB9 adapter to connect it to the CAN OBD2 port on the vehicle. You can also use the screw terminals. One little hint is just behind the DB9 connector are some solder pads. You have to solder them in such a way that it uses the correct pins, because there are two different versions of the same cable that may or may not work. Took me a while to work that one out, but this will cost you probably about $35 to $40, 35 to 40 UK pounds. The website there is in the UK, but I believe he sells them in the US as well through other outlets. Here again is a screenshot of CANdump showing CAN messages from the CAN bus. Finally, out of the cheaper end of the CAN adapters is the CANtact, which is by Eric Evanchek, linked down the bottom there. This, I believe, is based on an STM32 and inbuilt CAN controller and CAN transceiver. This has got the same 9-pin adapter on the end, but a large USB-B connector. These retail, I believe, around $75, which is okay if you're in America, but if you're in the UK, you get stuck with customs and VAT. The jumpers in the middle there are for changing which pins go to where, slightly similar to the Pi CAN. He's currently on Kickstarter though, doing the CANtact Pro, which uses a slightly different processor but gives you two isolated CAN FD channels. Worth a look if you're interested in backing a Kickstarter. I might end up backing it myself if I haven't already done by then, by the time this goes out. So on to the instrument cluster itself. Here is the instrument cluster. It came from a Citroen DS3. They are not sold in the US. None of Citroen's group vehicles are sold in the US. This cost me about £30, which is probably about 25-ish dollars. You can get these from eBay, at the scrapyard yourself, vehicle dismantler, recycler, etc. This one has a OBD2 port underneath in the middle there. This is because I use it for training purposes. So this is a very similar instrument cluster with regard to messages as my car in the box. Little hint here, listen up. The car in the box is based on a Peugeot 208, which is a similar size vehicle to a DS3. However, it's just got a slightly different cluster. The message structures are very similar, if not the same. Here's the back of the instrument cluster. As you can see, there's some screw holes which hold it into the vehicle, one of which screw holes is blocked up with a barrel jack socket. You've then got a 18-pin connector for the device. If you are purchasing it from a vehicle recycler or scrapyard, see if you can get the cable as well, because it's always easier to attach something to a cable that goes in specifically to that device. as opposed to using DuPont cables and trying to try and select the right cable. Just zoom in on the plug itself. It's 18 pins. Pin 1 is bottom right, pin 9 is top right, pin 10 is bottom left, pin 18 is top left, and as you can see there, pin 8 is CAN high, pin 9 is CAN low, pin 15 is 12 volts, and pin 18 is ground. Some of the other pins do things, some of the other pins do not, but be careful because you may break things if you send the wrong voltage up the wrong pin. So how do you work out what pin does what? You have to get the wiring diagram. This is the wiring diagram for the DS3 for the head unit and infotainment system. And if you zoom in right in the middle of there is the device that is the instrument cluster. As you can see, it has a little microprocessor and a couple of dials. That basically shows you what's inside it. It means it's got some brains, and it is the cluster. There is a key that tells you that 0004 is an instrument cluster. However, it might be called something else, as in the language that it was originally written in, so in French. Looking at the wiring, it says 18V, which means it's 18 pins. BA means the color of the plug, which I believe is white. I can't remember. I may be wrong, but pin 18 or green is ground. Pin yellow is switched live. Pins 8 and 9 are CAN high and CAN low. It's sort of potluck on that one. You might get it right first time, you might not. But if you don't get any messages back out of the device, swap them over, see what happens. So power supply. This power supply here came from Amazon. It's a USB to 12 volt barrel jack. So USB at 5 volts at one end. It's got a boost converter in the middle. That then can step it up to the 12 volts that is required for the cluster. Technically, you need 13 point something volts if it was running with the alternator at full chat, but 12 volts should be enough. You could potentially use an ATX power supply, but I think it's overkill to have something that could potentially put 40 amps through it. So this is slightly safer. So on to the Linux software. When using CAN under Linux, you need the package that is called CANutils. If you're running on a Raspberry Pi, apt-get install CANutils. It will then install all these components here. CANdump will basically output all CAN messages from the bus that is currently coming off the CAN bus. CANsniffer shows all messages that are changing on the bus. It does not show by default any message that is static. It will remove them from the screen, so it only shows you stuff that's changing. You can then make it highlight things to show when things change and when things don't. You can make it show all messages, but it's just one of the options. CANsend allows sending of a single CAN message. If you're very good at shell scripting, you may be able to use that to send multiple messages in a for loop. It's not that easy to do unless you're really shit hot at doing bash scripts. CANgen is a slightly better version of the same thing in that it can generate messages either randomly or with specified logic. Finally, the last part is CANplayer. Basically, this will replay messages that you have logged to a text file using CANdump. Excuse me. And then you can then record something on a vehicle, bring it back to your cluster, and then replay it and see what happens. And then by selectively grepping those messages, you could replay it and find out which message does the speed, which message does whatever, or just fuzz it and see what happens. So, shall we start fuzzing now? the Discord channel, or hit me up on Slack or Twitter. I'd like to say thank you for everyone listening. Please don't break your own car, but give me a shout if you want a NanoCam PCB. That is me done for today. So thank you very much.